The second video lesson of lesson 3.2 is still evaluating expressions using logarithms. What they want us to do is they want us to get familiar with some of the basic properties of logarithms. And this is true for any base that's an eligible base. So if we think about our related exponential function where we have y equals b to the x, our eligible bases for an exponential were any value for b as long as b was greater than 1. If that was the case, it was exponential growth. And the only other eligible base that we had was any base that was between 0 and 1, and that was decay. And since logarithms are so closely related to exponentials, and that's what this was, it's exponential models, the base is only eligible if it's greater than 1 or between 0 and 1. So they're saying for any base that's greater than 0 but not equal to 1, that's really relating the same information that we have here, only it's in logarithms. And since logarithms are the inverse of exponentials, they're going to have some very closely related ties to it. Then the following statements are true. They're saying no matter what your base is, the log base b of 1, try that again, the log base b of 1 is equal to 0 because, okay, so now we're doing this, why is that true statement? So because if we change this to the exponential format, so relating it back to an equivalent format, we know that this is the exponent and this is our base. B to the 0 equals 1. And we know that anything, no matter what the eligible base is, raised to the 0 power is equal to 1. So this statement has to be true. So the log base b of 1 is always 0. So that's a blanket statement we can make for any of those. Okay, so then the second property that we have to deal with is one that's equally intuitive. It says a log of base b of b equals 1. So again, I'm going to change it into our exponential format to give us some more meaning behind this. So I can change this into the log is base b, so the exponential has to be base b. Logs always tell me what the exponent is, so the exponent is b to the first, and that has to equal to antilog b. And it's absolutely true that b to the first power is equal to b, and b is equal to b. So that's another property. What is the exponent you raise b to get b? To get itself, you always raise it to the first power. Next property says we have the log of base b of b to the x equals x. Now what this statement is asking us to, or telling us to find the exponent I raised b to get b to the x. So find that exponent I raised b to get b to the x. Well, this is true because, again, if I change it to the exponential format, the base of this logarithm is b. The exponent that the logarithm is saying it is x. X is the exponent I raised b to get b to the x. And that is another way of writing the same information they have there, and that's the because statement. And our final rule is if we take b raised to the log of, I have a hard time reading it, but it's got to be a b. Let me try writing it so it's a little bit more clear. It's b raised to the log of base b of x has to equal x, and they're saying, well, as long as x is not equal to or greater than 0, we'll be fine. So we'll look at that restriction a little bit. So this is true because the log of base b of x is equal to the log of base b of x. So what I'm going to do is, this is more or less written kind of in an exponential format, so I'm going to try to change this into a log format. So rather than rewriting it as an exponential, I'm going to do a logarithm. Well, it's got to be the log of base b, which is here, that's the base of our exponent. Logarithms always give me the exponent. Well, this was the exponent on this format, so it has to equal log base b of x, and it's the log of the antilog, and the antilog sitting right here, which is x. So log of base b of x is equal to the exponent log base b of x. That is also true. So there's kind of the becauses, and that's what they're saying in here as well. So there's some rules that we really need to know. These rules are good no matter what the base is. As long as it's an eligible base, they will follow along with those. Now the examples they give with these aren't too difficult. It's a log of base 9 of 81. Again, we want to find that exponent. What is the exponent I raised 9 to get 81? And that was a little easier than the other ones that we've had. It's simply 2 because 9 squared is equal to 81. So the exponent is 2. In the second example, this one's going to utilize one of those properties that we had up there, log base 3 of log 3 raised to log base 3 of 1. Now it's asking me to go and find the antilog in this one. So it wants to find x. So since this is already written as an exponential, I'm going to write it as a log format. So this is log. The base of the logarithm has to be the same as the base of your exponent, log base 3. You always take the log of the antilog, which is x. It has to equal the exponent, which is log base 3 of 1. So what value of x will make these two log statements equal? Well, you got the log of base 3 in both of them. So if you take the log base 3 of 1, what does x have to be? Well, if the logs are equal, then the arguments have to be equal for x equals 1. Okay. In this problem, here's one thing I'd like to introduce to you and talk to you about, and that is how these are inverse operations. If you have 3, an exponential of base 3, raised to the log of base 3, these are inverses. An exponential base 3 and a log base 3 are inverse operations of each other, and therefore they will reduce, and what you get left is your antilog in your original, which is 1. There's another way of thinking of it. A third way of thinking of this, because this one sometimes gets hard for people to understand, is 3 raised to the log base 3 of 1. This statement here, if we just take this alone, it says we're supposed to find, forget this 3 for a moment. If we have log of base 3 of 1, it wants us to find the exponent we raised 3 to get 1. So what is the exponent I raised 3 to get 1? Well, the only exponent I can raise 3 to get 1 is when x is equal to 0. So what that means is the log of base 3 of 1 is 0. So then we take 3 raised to 0. So that's evaluating this. It's 0, and 3 to the 0 is equal to 1. In one of those 3 ways, we've got to connect to the fact that we're going to get 1 for our result.